I recently did a Let's Play of Alan Wake 2, and in it there is a core game mechanic called the Mind Place. Essentially, it is an area outside the normal play space where you can explore a case wall, upgrade weapons, and look at collectibles. It's kind of cool because it isn't just a 2D pause menu that you pull up, but instead a 3-dimensional space that you can walk around in. So in today's video, I'm going to mimic switching back and forth between that sort of extra-dimensional gameplay area. The video is meant to focus on the core mechanic of switching spaces, so don't be too disappointed when the end result isn't a fully functioning, Saga Anderson-inspired mind place. Do you just want the end result without having to listen to all the explanation? Well, here is the basic blueprint pattern that you can consume and then go about your business. There are 4 key elements to make this switching work. The whole thing isn't very complicated and involves skills that, if they aren't already in your tool belt, you should absolutely commit them to memory, because they can be used in a lot of different situations throughout future games. I should mention, my starting point is a new level in a project that is based off the trusty third-person character template. Okay, so let's go ahead and start with creating 2 playable characters to switch between. The first character will be the one we spawned into the level with, and is based off the third-person character blueprint. This character is already taken care of by our player start object in the level. Our second character will also be based on the third-person character blueprint, and we can create that object by dragging the blueprint into the level. The blueprint can be found by opening the content drawer, navigating to Content, Third Person, Blueprints. So now I'll just drag it into the viewport, and voila! Our Mind Place pawn sits like an empty shell just waiting for us to take control of it. Might be useful to change the name of the pawn in the outliner in case we need to search for it later, so I'm going to rename it to Mind Place Character. Let's move on to objective number 2, which is where we start piecing together the logic for our switching. When prototyping things, I almost always use the level blueprint because it is kind of a nice central hub that the game session revolves around. So I'm going to open that up by clicking the little blueprint icon and selecting Open Level Blueprint. Now I'm going to be switching back and forth between characters, so I need to somehow reference which character I'm going to switch to next and have a way to get back to the character I just switched from. What a perfect situation to use a couple of variables, so I'm going to make those. And first is the character we spawn in as, which I will call world character, and second is the character we have hidden away in our mind place, which I'll call mind place character. These variable types should be of the type we wish to use, and for my purpose that means they should be an object reference of type BP third person character. Now that we have our empty variables defined, I need to set them, which I will do on event begin play. Starting with our world character, I need to get the character type our player controller possessed after the game started. This can be accomplished with a very useful function called getPlayerCharacter. I want to use the output of this function to set our world character variable, but you'll see I can't connect the pins because of a type mismatch. I want to keep in mind the object returned by the getPlayerCharacter function doesn't have to be a third-person character. For example, if I want to reuse this level in a different game mode, I could spawn in a starting character of a different class. That class may not be compatible with a reference of third-person character. To fix the type reference, I will cast the character object I get from getPlayerCharacter to the third-person character object type. This isn't a very robust solution, and I'll try to remember later on to explain why. To set our Mind Palace character variable, it is pretty easy. We just need to get a reference to the character we placed in the level. We can do this by going back to our viewport, selecting the character, going back to the level blueprint, right-clicking, and choosing the Create a Reference to Mind Place Character option. Drag out from the pin and start typing Set Mind Place Character to find and select the Set node for our second variable. Make sure all the execution pins are hooked up, and then compile and save. At this point, we could put a couple of breakpoints into the blueprint and make sure the variables are being set correctly. I'm now ready to do the actual switching. Here's a flowchart for the logic, and as you can see, there isn't much to it. I'll press a button, which I've chosen to be tab, and check to see if the current player character is equal to the one we spawned in as. If it is, I'll switch over to play as the mind place character. If instead I press the tab key and I'm not the character I spawned in as, it means I've already switched to the mind place character, so I need to switch back. Seems pretty simple, so back in our level blueprint, I'll right-click in the event graph, search for the tab key event, and select it. From the execution pin, I'll use branch node for my if statement. The branching condition is if the player controller is currently possessing my spawned-in world character, so I'll use the getPlayerCharacter function again to see what I'm currently playing as, and see if that is equal to the world character variable I set on begin play. I'll connect the result of the equals operation to my branch node. If the current character equals my spawned-in character, I need to possess the mind place character. So from the branch node, I'll pull off a connection from the true exec pin and search for the possess node. The target is going to be the player controller, and the pawn reference is going to be the mind place character. Get the player controller by right-clicking in the graph, searching for and selecting the getPlayerController function under the game category. Get a reference to the mindPlace character variable by dragging the mindPlace character variable from the My Blueprint panel and choosing the Get option from the pop-up. Connect all the pins. Going back to the branch node, if our branching condition is false, or I am already possessing the mindPlace character, then I need to switch back to the world character. Pull a pin off the false exec pin, and again search for possess. The target is again going to be the player controller, and the pawn reference is going to be the world character variable. All right, time to play the game in the viewport and check our work. Amazing. And it turns out we've also done objective number 3, which is ensure only one character gets player input by doing that little jump there. I want to point out a quick setting that for this project I set quite a while ago and have forgotten about, but I don't believe it comes set by default. And the thing is, if I click play here, and if I look in this setting is disabled, if I jump and switch characters, this guy is floating up in the air, and that's not something I want for this particular prototype. And the setting that controls that, if I open the BP third person character, is called Run Physics with No Controller. So if I check this, compile and save, and then play again in the editor, my character will complete its physics-based movement, which is what I want. So if you didn't know that setting existed, there you go. If you've forgotten about it, also there you go. Now that I have my character switching feature in place, the last thing to do is objective number 4, creating an invisible area for the mind place. After looking through my library assets, I finally decided on a large bank asset from marketplace creator Liertes Studios. I think that's how you pronounce it, Liertes Studios. And it's just been sitting in my library for some time, so let's get to using it. I've already added this asset to my project, so now I'm just going to go ahead and drop it into my level. And I will quote unquote hide it just by simply dragging it down below the ground plane. And then I'm going to move my mindPlace character from the viewport to be settled up somewhere inside that building. According to the camera, it's already dropped in somewhere. Perfect. Okay, now all that's left is just to test this out and see if it works. Okay, so I'm my world character, then I press tab, and I am stuck jankily inside a wall, it looks like. I'm not sure exactly what I was looking at before, but that was not a character placed inside. Oh, that was from an earlier experiment. So the engine will sometimes get kind of finicky for me, and when I right click and try and drag or something, somehow the click loses focus, and then just weird stuff happens. Okay, my character is now placed in the building. It looks like the camera is kind of clipping through a wall, so let's bring this forward. And again, ignore this other person for now. Let's try this again. Get to run around. I press tab. Now I'm in the bank. Very cool. I do my mind place stuff. I tab back. I'm back in the open world. I tab mid jump. Kind of run around again. And I am done. That is the mind place mechanic. Which, even though I think this video is going to be a little longer than I thought, the actual process for making it was fairly short. So, I think that might be time for some bonus content. Remember how I said casting to a third-person character blueprint could cause problems down the line? Of course you do, because your mind is like a steel trap. Let me briefly explore this claim by switching the spawned-in character as a first-person blueprint. Before I do that, I'm going to go ahead and go to this cast failed, and I'm going to print string. Hey, dummy. Cast failed. Hop into my viewport. I'm going to go into world settings, and you'll see I've already changed it, but I'm going to go ahead and select first-person game mode. If I click play, I'm now a first-person character. I'm going to hit tab, and nothing's happening. I'm going to set a breakpoint. Click play. The object coming in is a first-person character. And so if I step to the next node, I should be here. Perfect. Okay, you'll notice there were no errors. There was nothing to really indicate why we weren't switching characters when we hit tab. But it's because these variables never get set. So when we come to tab here, then this is never going to be equal to anything because it's null or unset. We can add a breakpoint just to showcase that. We'll remove this breakpoint. Hit tab. And here we go. This condition is always going to be false because world character is unknown. So how can we make this a little bit more robust? Well, what if we instead change our variable types to the parent class of our third-person blueprint character? It would also have to be the parent class of whatever other character you want to use. So let's go ahead and take a look at first-person character. And you'll see the parent class is character. And if we go to third person, we can see that the parent class is also character. So let's go ahead and set this to be a character reference. We're going to change the variable anyway. Change the variable anyway. And now do I even need to do a cast? Probably. Oh, probably not. So let's go ahead and just bypass this. And see how that works. Compile, save. Press play. Run around. Hit tab. And there we go. Now, of course, we switched game modes, so our controller, we no longer have the ability to control this third-person character. We'd have to make some tweaks to our blueprint, but we can tab back and forth, which is what we wanted. So there you go, just a little something if you wanted to make your blueprint a little bit more robust. I want to spice up my transition. So I'm going to add a fade to black and fade from black. I'll also stop the player from doing inputs while the fades are in progress, just to punish them a little bit if they happen to hit the wrong button. That's right, you will have to wait until the animations are completed. In my level blueprint, I'll add a start camera fade node, and this node needs a reference to the player camera manager, which we can add by getting the player controller and letting the system do the conversion for us by connecting the two nodes together. I first want to fade to black, so I need to set the from alpha value to be 0 for transparent, and transition it to fully opaque by setting the to alpha value to 1. I'll use a noticeably large duration of 1 second. Notice how the fade doesn't finish before possessing the next character. I'll fix that by adding a delay node of 1 second in between the camera fade and the possess nodes. To fade in after switching characters, I'll use another camera fade and delay after the possess node. To stop my player from entering inputs, I'll add a node called disable input, and I'll use both the actor target with my character reference and my player controller. It is quite important to remember to re-establish input for the player, and I'll do that after the character switch and the fade from black. Copy this for the other path of our branch statement, and the transition now happens on both switches. This video is now much longer than I anticipated, but I would like to point out now that I have the basic character switching working, I would clean up this code by putting logic into reusable functions, perhaps encapsulating the mind place character in with my bank building, moving the level blueprint logic into a game mode class, possibly, and set some input mapping for my switch button, among many other things. So that is it. As always, thanks for watching. Now go make something cool.